Hello everyone, I have recently been studying machine learning at university, so today I would like to cover some basic concepts of gradient descent. Gradient descent is introduced as a fundamental algorithm essential for optimization tasks in machine learning. It aims to minimize functions with potentially many variables by using first derivatives or gradients to determine the direction of descent. Gradient descent is an iterative optimization algorithm used to minimize a function by moving in the direction of its negative gradient. In optimization, this corresponds to finding the minimum of a cost or loss function. In machine learning, it helps optimize model parameters. The gradient of a function is the vector of partial derivatives. Gradient points in the direction of the steepest ascent. Moving in the negative gradient direction reduces function most rapidly. We want to find the minimizing point x equals argmin of a function. It means the point where f equals f mean, the point where the minimum is reached. Gradient descent starts from a point x0, then we go down along the gradient. We recompute the gradient at the new point x1. And at every step we follow the gradient. So x plus 1 is xk minus sk, the step size, times the gradient of f at xk. Now moving on to convex functions. These functions exhibit properties that make optimization easier. The condition number, the ratio of the largest to smallest eigenvalues of the Hessian, is critical. A high condition number indicates slow convergence. Here's the example. The function is a pure quadratic, two unknowns x and y. So every pure quadratic we can write in terms of a symmetric matrix. And in this case, x squared plus bx2 squared, the symmetric matrix, is just 2 by 2. It's diagonal, it's got eigenvalues 1 and b sitting on the diagonal. I'm thinking of b as being the smaller one. So the condition number, which we'll see, is all important in the question of the speed of convergence. In this case, the largest is 1, and the smallest is b. So that's 1 over b. And when 1 over b is a big number, when b is a very small number, then that means that the function is harder to optimize due to the elongated valleys, and we very slowly approach the point of minimum. When the matrix is symmetric, that condition number is lambda max over lambda min. If I had an unsymmetric matrix, I would probably use sigma max over sigma min, of course. But here the matrix is symmetric. The gradient is 2x and 2by. Then we compute the next point xk. So the only thing left that requires us to input some decision making is a step size, the learning rate. We can take it as constant. If we take too big a learning rate, the xk point will oscillate all over the place. If we take too small a learning rate, too small steps, it takes too long. Okay, that's it for today. As I learn more about ML, I hope I will be doing short reviews. Bye bye.